Hey chemists, just want to talk you through some indirect and bag titrations today. So this is kind of an extra layer of complexity to our standard stoichiometric direct titrations that we've looked at in the past. So the key concepts here is a bag or an indirect titration is generally a two-stage analytical technique. You've got a reactant, which we can call A, of unknown concentration is reacted with excess reactant B of a known concentration. So the word excess means more than enough of. So essentially really saturating it with that excess reactant. And the key there is we know that concentration. And the whole point of it is to find out the unknown concentration of reactant A. A titration is then performed to determine the amount of reactant B in excess. So essentially, how much of reactant B was over the amount that was required to react with reagent A. So we use an indirect or a back titration, and we're going to do one of these in class as our SACE task to determine the concentration of hypochlorite in bleach, which is the active component of bleach. So we're going to use these when one of the reactants is volatile, for example, ammonia. Guys, volatile means it's generally kind of unstable. So it may emit some fumes. It basically just doesn't exist in that pure form for too long. So if we're performing a titration in terms of a direct titration, if something's volatile, then that concentration is going to decrease quite quickly over time, and you're not going to get an accurate result. If an acid or base is an insoluble salt, for example, calcium carbonate, if it's insoluble, that means it's not going to dissolve in solution, which means a titration isn't going to work. A particular reaction is too slow. With a titration, you want that reaction and that color change to occur instantly. It's hard enough to get that endpoint. You have to go quite slowly and carefully at the end. Imagine if you had to wait for, 20 seconds, 30 seconds before any sort of change happened. You'd be there forever. A direct titration would involve a weak acid or a weak base titration. So the endpoint of the direct titration is very difficult to observe. Essentially, if an experiment that's suitable for a direct titration would need to be able to have that color change, which is the endpoint, to be very close to the point at which A and B neutralize, which is the equivalence point. And if those two don't match up, then a direct titration is not going to be an appropriate way to determine unknown concentrations. So first method, indirect. So excess reagent is added to a solution being analyzed. The reagent converts the substance we're interested in to one that can be titrated against. So essentially, we're doing a reaction to make something new, and then we perform the titration against that new substance. So for one of the reasons mentioned in the previous slide, we would be changing to something else. So indirectly, finding that unknown concentration. So once the concentration of the product is known, so we know how much we've got, then we can calculate the concentration of the original substance. This example here is very similar, and it's using the exact same equation to one that we're going to do in class. So I think this is a great question to kind of have a look at. So we've got a solution of sodium hypochlorite. So basically we're using bleach, and bleach has an active ingredient, which is called, so the part that makes it work, which is the sodium hypochlorite, which is NaClO. That's sodium hypochlorite, and it contains 12.5% available chlorine. So the amount of available chlorine in a commercial bleach solution was determined by volumetric analysis. 20 ml samples of the diluted bleach solution were pipetted into conical flasks, to which excess potassium iodide and dilute sulfuric acid were added. So I think it's really important just to make sure you are kind of underlining the really important parts here. So excess potassium iodide, and potassium iodide, if you look at the equation, so where is the potassium iodide? There's no potassium in here. It's an ionic equation. So potassium is a spectator ion for this ionic equation. So you've got your iodide ions here. So that's the reagent in excess. So what's actually happening here is it's being converted to something different. So this is the reaction of the hypochlorite ions, and the iodine produced in the solution, so this here, was determined by titrating. So this one down here, this second equation, this is the titration. So by titrating with 0.100 moles per litre sodium thiosulfate. So that's your thiosulfate ion. So again, the sodium is the spectator ion. So this here is your thiosulfate. So that corresponds to that. Using starch as an indicator, the average titer was 12.75 milliliters. So you have your volume, and 12.75 converted to liters, 0.01275. So what we want to do, we're breaking it down step by step. So what's the number of moles of thiosulfate in the average titer? So for that, you've got a concentration, you've got a volume, so that's a relatively simple calculation, step by step moving down. Please pause this video, have a go in your books, and see how you go with this indirect titration question. Okay, so here are the solutions to the previous question. So again, just pause this, have a look at how you went, ensuring you're using correct units, ensuring you're writing down formulas and calculations. So even though it's just saying 1 mark, for example, for this, you need to get all of these steps correct, even the beginning when you've got that formula written down. So just pause again, correct your previous work and see how you've gone. Okay, next we have the back titrations. So with the back titration, a little bit different. So reactant A of unknown concentration with this, I guess, signified by this green bar here, is reacted with excess reactant B of known concentration. So again, this is really important. We know the concentration of reactant B and we're using excess, so more amount than the unknown reactant A. And then I guess visualizing the kind of reaction here. So you've got a certain amount of reactant A and this much of reactant B will react with it until this is kind of being used up. And then you've got this much of reactant B that will be left over in the reaction flask. And we say that that can be reactant B, the excess of reactant B. So this is the I guess, more than you've used. A titration is then performed to determine the amount of reactant B in excess. So essentially, you pick known reactant X, which is known to react with reactant B. That's the titration that's performed. And then you work backwards with one extra step to figure out, okay, that's how much excess there was based on my stoichiometric calculation here. So I figured out the excess of reactant B. I know how much reactant B initial I used in the first place. And then you do a subtraction. You go initial, take excess equals, that's how much of reactant A I must have had. So this is what I'm talking about, just that subtraction at the end. So B initial subtract B excess equals B reacted. So B reacted would be this, just moving back, this much here. And then just do a conversion in order to, so a mole ratio conversion in order to get reactant A. So this is an example of back titration. I'll let you read through this one. What I would recommend is to make sure that you are getting the key information of the question. So 25 ml of a solution containing ammonia, this much hydrochloric acid. So this is your hydrochloric acid here in reaction 1. So carefully looking at that, reading through the question, and it's just breaking it down step by step. So this is the first part, this is the second part, this is the third part. Pause this video on this question, give it a go in your books. So the first question, calculate the amount of excess reagent that did not react in the first reaction. This is what we wanted. There's no marks allocated to this, but this was that first step. So again, pause, make sure you've got it. This is the next part. Again, pause, make sure you've got it. Calculate the amount of excess reagent which did react in the first reaction. So this is where you're going to use your subtraction. So you know the number of moles of initial hydrochloric acid and reacted hydrochloric acid. So initial subtract unreacted to get reacted. And then the last step, again, pause, now you know the amount of chemical that has reacted, and then you can use mole ratios in order to determine the concentration of your original unknown substance of ammonia. Guys, thank you so much for watching the video. I hope that you were able to learn a little bit about indirect and back titrations. Use this as a supplementary resource when answering your questions. Have an awesome day, and I'll see you next time.